You know, in the world of AI, the mantra for the longest time has been super simple. Bigger is better. More data, more power, more parameters. But what if that's not the whole story anymore? What if we're about to see a classic David versus Goliath story play out, but for artificial intelligence?
So, in one corner, you've got Microsoft's RStar2 agent, a pretty small model, all things considered, with 14 billion parameters. And in the other corner, the heavyweight champ, Deepseek R1, with a mind-boggling 671 billion. Yeah, you heard that right. It's almost 50 times larger. So in a straight fight, you think you know exactly where to put your money, right? Well, this wasn't a straight fight.
Okay, so the challenge was this. They both had to tackle some seriously tough high school level math problems on a test called A-Me. And this is where things get wild. The little guy, RStar2 agent, didn't just hold its own, it won. It scored a crazy 80.6% and left the giant in the dust.
So this brings up the big question, right? The question for this whole explainer, really. How on earth is this possible? How does a lightweight model outsmart a giant? And the answer, it turns out, isn't about thinking bigger. It's about thinking smarter.
All right, to really get this, we got to first look at how most AI models have been taught to think up until now. It's this whole idea of just thinking longer.
This technique is called chain of thought reasoning, or COAT for short. And you can literally picture it like an AI showing its work on a math problem, you know? It writes out every single logical step, one after another, hoping to land on the right answer. And for a while, this was a pretty big deal.
But here's the catch, and it's a huge one. This method has a fatal flaw. If that AI makes even one tiny slip-up early on in that chain of thought, say in step 2, that mistake just snowballs. The whole rest of the chain gets corrupted and poof, the final answer is completely wrong. It has no way to pause, check its work against the real world, and fix the mistake.
And that's where this new idea comes in. This is the secret sauce behind our little underdog's big win. It's a concept called agentic AI.
So what exactly is an agentic AI? Well, to put it simply, it's an AI that doesn't just sit there and think in a straight line. Nope, it's an active player in the game. It can look at its environment, it can make decisions, and, this is the most important part, it can actually use tools to get stuff done. And the key here is that it's not a one-way street. It's this constant, dynamic loop. The agent sees a problem, thinks about what to do next, and then it acts. But, and this is critical, it then looks at the feedback from its action, learns from it, and adjusts its plan. It's this cycle of act, observe, learn, repeat.
Okay, so this brings us right to the secret weapon that RStar2 agent had up its sleeve. It wasn't just thinking harder, it was thinking with tools.
The difference here is so simple, but it is absolutely profound. Think about it like this. A traditional AI tries to do super complex math all in its head. An agentic AI, it's smart enough to realize, hey, why don't I just use a calculator and a scratch pad to double-check my work as I go?
So how does this actually play out when our RStar2 agent is solving a problem? Well, first, it thinks about the next logical step. But here's the game changer. Instead of just moving on, it stops. It actually writes a little piece of Python code to test that step. Then it runs the code and looks at the result. Did it work? Did it get an error? And based on that real-world feedback, it tunes its thinking and figures out what to do next.
This whole back and forth, this is what's called agentic reinforcement learning. Basically, the model is being trained like a student. It gets rewarded not just for getting the final answer right, but for using its tools, that Python code, effectively along the way. It's literally learning how to be a better problem solver.
Okay, so let's zoom out for a second. What does all this mean for the future of AI? Because this one result, it could be signaling a huge shift in the whole field.
For years, right, the AI race has been all about building bigger and bigger models. But what RStar2 agent is showing us is that the new frontier might not be about sheer size at all. It's about being clever, being efficient, being strategic. The new motto isn't bigger is better anymore, it's smarter is better.
So why does this matter to you? Well, a few big reasons. First, it means we can have much more efficient AI. We can get that top-level performance without needing these insane, super expensive computer setups. That makes powerful AI way more accessible. Second, we get more reliable AI. Because these systems can actually check their own work, they're way less likely to make those weird mistakes or hallucinate things. And finally, it just makes AI more capable. I mean, if a model can learn to use a calculator, it can probably learn to use just about any digital tool you throw at it.
And yet, this idea goes so far beyond just solving math problems. Just imagine an agentic AI in a robot, using sensor data to adjust its grip in real time. Or think about healthcare, where it could be scanning patient data and the latest medical journals to help doctors with a diagnosis. Or even in video games, creating characters that actually react intelligently to what's happening. The potential here is it's transformative.
So look, we just watched an AI learn how to use a basic calculator and a scratch pad to beat models 50 times its size. It really leaves you with one big question, doesn't it? If it can master that, what other tools could it learn to master next?